Okay.
A K in this question.
So-
You have to say cat.
Here's the story on number 7. Your De Broglie wavelength, that's a simple plug-and-chug type affair. That should be 1.2 times 10 to the negative 14 meters, okay? And this was the whole thing, is like the idea that particles travel in waves. Didn't make any sense, but they figured it out. So on B, you're going to calculate the kinetic energy. Again, if you wanted to use that kinetic energy equals P squared over 2M, that saves you a little bit of hassle. Or you can go old school and find the velocity and plug that into 1/2 mv squared. No matter what you do, you should get 9.1 times 10 to the negative 13th joules as your answer to B, not C. Now, once you have that, then it says calculate the value of D. That's technically known as the point of closest approach. So here's the basic idea, is that here comes proton flying in. Here's the massive nucleus. It's like a marble hitting Hank. It's going to bounce back. So at some point, it's going to store that kinetic energy as ooey. That's the whole point of the story. So ooey, and here's a common mistake. You have K, Q1, Q2 over D. It is not over distance squared, okay? This is not force. This is ooey. So here's the one thing that you have to watch. This is uranium-235. So one of the charges isn't just, you all are just used to saying, oh, they're 2 protons. Well, in that uranium nucleus, you have 92 protons. So that charge there, you've got to take 92 times 1.6 times 10 to the negative 19th. Just don't use 1.6 times 10 to the negative 19th. And then you are going to have another 1.6 times 10 to the negative 19th, which is the charge on the proton. So if you wanted to get fancy, you could take 1.6 times 10 to the negative 19th squared times 92, and that would get you the total amount of charge. And then you divide by that distance, and you do all that, and you get 2.3 times 10 to the negative 14th meters. Okay, so that should be that answer on C. Now, when you get, then it says that amount of energy is released when you get to D. Indicate whether the mass is greater than or less than the mass of the fission products. So here's the story. If you split atoms apart, energy is released because the daughter particles have less mass than the parent nuclei that you started with. That's the only way that it works. So this is how any fusion process works, is because your products end up with less mass than what you started with. Okay, that's how we get energy from the sun. It's the same. Now, so that answer should be greater than. You should have marked greater. Then it says calculate the mass difference. Do not make this difficult. All you have to do is use E equals MC squared. Okay? That's all you have to do on that mass difference. So you're told that you release 2.5 times 10 to the negative 11th joules of energy. This is the speed of light. 3.0 times 10 to the 8th meters per second squared. Solve for mass, you get 2.8 times 10 to the negative 28th kilograms. Okay, that's the easiest way to do it. Easiest way to do it. Now, there's a subtle thing. I know we're about out of time. There's one other thing. Oh, It's that second question, number 7, and it's got an electron and a positron orbiting around the stationary center, and they annihilate each other. When you get to that last question, is to determine the total momentum of the 2-photon system. Do not make that difficult. You have pure energy. You're going to create 2 photons out of this. Which direction do you think the photons are going to go? Opposite direction. So what do you think the momentum afterwards is going to be? Zero. Okay, so on that second number 7, where it says determine the total momentum of the 2-photon system at the end, that's going to be 0. So let me quickly write down the answers to that one. So A is, I did this in electron volts, 5.125 times 10 to the 5th EVs. This is one that starts off with the electron and the positron. B, you also get that exact same answer, oddly enough. C, you get 2.42 times 10 to the negative 12th meters. D, you get 2.74 times 10 to the negative 22nd Newton seconds. And then E is just 0. Okay. There we go, kids. So